On June 22, 1633, Galileo was put on trial at Inquisition headquarters in Rome. All of the power of the Roman Catholic Church seemed determined to squash the scientist. Under threat of torture, imprisonment, and even burning at the stake, Galileo was forced, on his knees, to abjure, curse, and detest a lifetime of brilliant and dedicated labor and thought. 10 cardinals sat in judgment of Galileo. Pope Urban VIII was not present in person, but he was there in spirit, for his personal feelings of anger and frustration were the driving force behind the proceedings. Urban realized just how seriously Galileo's new science challenged established church doctrine. Galileo had declared the book of nature was written in the language of mathematics, not in biblical terms. This is what our own scientists in the 21st century face when their discoveries and ideas go against orthodox science. Scientific doctrine as taught in major universities and the science as seen on public television. When discoveries offer nearly free energy and nearly free unmonitored telecommunication and internet access, some powerful people get nervous. Corporate economics and government power squash the new ideas because those new ideas literally spell disaster to the power structure of governments and disaster to the economic future of large corporations. In 2016, our Inquisition spends hundreds of millions of dollars on physical and medical science projects, grants given to pursue science that is based on false assumptions. Fighter jets and corn subsidies have become more important than science. Science and technology have become tools to make money, not tools to truly improve our lives or help us understand the universe. The advancement of our scientific and engineering knowledge is often stopped cold by the perpetuation of orthodox scientific doctrine. No money is available to the true innovators. This series of programs introduces the work of a few modern Galileos. These scientists show us their discoveries and discuss the science behind the discoveries. And the full lectures have not yet been suppressed. They are available to anyone who is curious about alternative views.
So this is the common transmission system. It's broken into three parts. Basically, we have the source of electricity, and we have the sink of electricity, and we have the transmission system in between. This is how it's commonly done. And it's fairly well understood, and it's a very basic geometric configuration. So before getting into anything fancy, it's kind of best to learn the basics on the stuff that's already here and everybody can agree upon. This is an introduction to Steinmetz's book, A Theory of Calculation of Transient Electric Phenomena. He covered all dimensions and interdimensional relationships in common electromagnetic systems, and 90% of this work is thoroughly ignored. So this is the basic common transmission system. This is what the tower would have looked like that I took the other photograph of. This thing operates at 500,000 volts, phase to phase, and roughly a current of 1,000 amperes. That's a lot of electricity. And this is just one of them. So there's all kinds of different types of transmission other than that. But the fundamental thing is transmission is in the dimension of space. So everything we're dealing with here is going to be a space or a dimensional orientated situation, and that is going to lead us, unfortunately, right square in Einstein's lap. So we're heading for it. So this is the basic electrical grid, as people call it. On the top we have the central generating facility. And then there's a very important device that follows it, and it's called the transformer. And we're going to engage in a detailed analysis of how a transformer operates, and also the fact that it operates in other modes that very few people understand, and that makes it basically a representative of the Tesla mode of operation, which is inherent in all these transformers. So then, out of that, on the top there, to the left, emanates the high voltage transmission lines, the heavy current material, copper, Edison related type of wiring and technology of the generating station is transformed by the transformer into a type of electricity that doesn't need all that type of material. It would be called a high potential or high impedance type of electricity. In this system, the transmission voltage is 69,000 volts. So the principal load of the generating station is the large factory, which has a transformer that steps this back down to the current-orientated electricity with lots of wire and magnetism and those kind of things, because it's safer to handle. It doesn't want to lash out at things, and it doesn't crackle. And it offers you an impedance buffer from the blast potential of the main line, which can be beyond human comprehension if you ever experienced one. So in this case, the transformer is not an energizer of the entire system, but it's like a transmission that couples the energy off of it safely at the ratios that the power plant can handle. And then finally, the line lands in the substation, which has a transformer that basically does the opposite of the one at the generating station. That's why it's called the substation. And then the voltage there is dropped, and then it gets into heavier copper, but it's not being distributed that far, and it's safer, so this starts to come into where people live. There are large factories that will pull off of that line. In this case, it's running a typical department DWP 33 kV. That's considered a safer voltage. And also the substation transformer acts as an impedance buffer, because chances are there's other substations that are in this grid that are not shown on this simplified diagram. So then at the end of the line, or at a proper point on the line, then we have another substation that follows the higher voltage substation, and this brings the electricity in where it's safe to be around humans. It's lower voltage, DWP runs 4800, 2400 is how it started out. But the power company doesn't care about safety anymore, so this substation has been eliminated from the system. So here we have Marconi. Now, Marconi is a very interesting guy on both the positive and negative level. So we'll get into a little bit of that. Marconi was good buddies when he was in high school with Professor Righi, who in Italy had duplicated all of Hertz's ideas and developed them into what are called centimeter waves, which today we call microwaves. And you could beam these things and you could reflect them. And Marconi figured, well, he's going to produce a radio system or a method of communications utilizing these waves. He was, you know, the kid, the boy electrician type guy in Italy. His family, you know, was wealthy. Jameson whiskey is Marconi money. I think it's actually known by a lot of people. And so the rich, you know, young boy experimenter produced something that worked and attracted people's attention with it. This finally led to his idea of what Tesla was doing, is to make it all elevated capacity and then tune the rest of it out with an inductance instead of having a smaller system of higher impedance. And of course, this thing is very prone to transverse induction to the ground by its very shape, but you can use it like a capacitor and try to transmit that way. Unfortunately, the Righi idea, which is fine for microwaves, is not good for these very low frequencies that these people. So this is the electromagnetic wave from the Hertzian oscillator that I already described. So these are the components of magnetism and dielectricity and wavelengths and all that. So this is what emanates from it. So you have the transverse inductions, which are the electricity, And then you have the direction they go in space, and by their nature of broadside drag, these impedance flow through space, and the ratio between their two quantities determines their velocity to be the velocity of light, which we'll get in later. Now we have David Sarnoff. So David Sarnoff took Marconi's ideas because he was Marconi's protege and formed them into a business plan of broadcasting and communications, and eventually became involved with RCA with Alex Anderson, and then David Sarnoff produced what we now call radio. Didn't do any of the work himself, but he was a very skillful manager. When the Navy gave Marconi the boot, Sarnoff became one of the principal operators in Let's Construct Radio Technology for America, and this is the guy that drove it through. And that's his beloved logo. So this is the type of radio and space broadcasting we have today, like a television antenna. This is a basic television antenna, probably for UHF broadcasting, and it is purely electromagnetic, and as you can see, it almost looks like the electromagnetic wave itself. So how did all this stuff get started with magnetism and EMFs and things that people don't even know the terms of? Well, we can't talk about this stuff until we know what the terms are, so now we're going to have to go get our degree in electrical engineering. Electromagnetism. Now, before that, magnetism was associated with something from some magic metal that you got from some mountain next to, you know, where the Ark landed and it pulled the nails out of ships. But at any rate, this magical substance could impart its virtue to other magnetizable substances, and then out of that, magnetism and experimentation with it came into being. But it was like electricity was in the old days. You really couldn't do with it anything with it. All you could do is move it around. You could communicate it to other bodies, but it was something that was weird, and you know, and the spirits drove it. So what Faraday, through his research, his most important experimental development was this electromagnet. Now with the electromagnet, you can make the magnetism go on, you can make it go off. And it also makes the magnetizable material jump around. So the permanent magnet has the magnetism stuck inside. The electromagnet derives its magnetism from a little understood process called electric current, which is associated with the metallic structure that surrounds it, which is generally known as the conductor. But it has to be always in this circular form. This is what enhances the situation, because the current always wants to be around the magnetism. This is an important thing when you're dealing with the tubes of forces, this what's called curl relationship, where the straight lines are defined by an associate geometry, which is in a curl configuration, and this is the very heart of electromagnetism. So this is how basically alternating current and oscillation currents and all these things came to be understood, and then Tesla applied this to his vacuum tube work, and it was very instrumental in his discovery of radio. So this is his induction coil taken to the extreme. Needless to say, everybody knows about it and has heard the stories. And he's not really sitting in there. It was a multiple photograph. But he did go through one of those disasters, you know, like when you smell that smoke reality, like earlier today. Except his was a little more extreme. He was inside reconnecting the wires, and somehow the switch had become unbalanced, or you know, some kind of spring mechanism or whatever screwed up and slammed the switch shut and turned the thing on when he was inside. And he was, you know, obviously terrified, and he had to crawl out under the primary winding, which is connected to a 50,000 volt transformer with capable of 50 kilowatts. And the RF potential around him is, you know, beyond belief. And he's shimmying on the floor, crawling like a crab, trying to get out of this thing alive. And that's the closest Tesla came to dying. So Faraday also led to another device, and this is particularly important in the study of and understanding of transmission theory, is the telegraph. So because the electromagnet can be turned on and off, what you can do then is you can have a piece of iron jump back and forth. So in a certain sense here, with the telegraph sounder, these are the electromagnets, and this is the movable core, because this is the first motor. It was a joint effort of Samuel Morse and Joseph Henry, who the Henry of inductance is named after. Henry is referred to as the Faraday of America. And Morse didn't know anything about electricity, but he invented the first digital code, and this represents the first digital transmission system. So the complication with the grounded telegraph is there's rivers of electricity swirling around inside the Earth. This is a map of them at some specific time in some specific relationship that I don't know about. We just captured these things off the internet to use them as illustration, but this shows you there's places where they're current loop and there's places where they join, and it just happened to be that the telegraph system went right through here, which is right in the middle of the whole blast. All the telegraph sounders started clattering away on their own, and things started getting out of control, and as the solar flares got stronger, it got even scarier. Aurora borealis started appearing in the telegraph's office, and fires were starting, and it was getting crazy. So you couldn't disconnect it. It was like some inductive discharge. You try to disconnect the wire, and this aurora would come off of the end of the wire and dance around in the office. Well, you know, the physicists might have a hard time explaining that, I would think. So that passed, and grounded telegraph fell out of favor. The main complication today about using ground return is the massive zero sequent currents that the power company are presently inducing into the system that flow in these paths and give rise to massive earth currents of electricity that cause interference. So this basically led to the idea that there's electric waves inside the Earth and current flows, and that the Earth itself is an electrodynamic system in its interior. So this leads to Tesla and Alexanderson and the development of these telluric systems and how they were abandoned. So this is the basic Tesla system. Everyone's seen the patent. The communications is not between the elevated capacities, it's between the ground terminal. It's just like everything else. There's a coil and an elevated capacity like we've seen in pretty much everybody's idea, but it's a little different in this manner. This is his Colorado unit. We can see the elevated capacity is here. The induction coil of massive proportions is on the inside. And this is his more of his refined idea of how I would do it. I think it's not, the geometric proportionality of it has a lot of questionable ratios, but in the patent drawing, I don't think you really strive for specific accuracy. But in practice, Tesla really hadn't built much like this that has been seen, but Wardenclyffe will remain an enigma, and we can make no interpretations. So, following Tesla is Ernst Alexanderson. Tesla's system was history when he got going. He came up with another type of ground transmitting antenna, but deliberately said in his patents that he was transmitting electromagnetically, and we will mathematically demonstrate later that there is no possibility that any of these structures can radiate any electromagnetic energy whatsoever. Where the Tesla system never really got to be proven, the Alexanderson system was put into service, and it knocked the Navy out of their chair, and they formed the Radio Corporation of America to administrate it, with David Sarnoff as manager, and Alexanderson became the chief engineer. So he was taken away from Steinmetz to build the basic groundwork for Radio Corporation of America. Alexanderson had developed Fessenden's alternator into monstrous electrical devices that were capable of 200 kilowatts. And this was enough power to basically excite these large antennas, which we'll get into later, and it replaced all the giant coils and capacitors and sparks and everything else of the Marconi system that preceded it that never really seemed to produce much of anything that worked in the long run, except under favorable circumstances. So this is what basically made the system possible. Then he came up with his waveguide. They call it an antenna. This is not an antenna. It transmits in the ground. This is the transmission structure that affects the transmission in the ground. This is the later model that became established that everyone's understood, but the prototype ones of Bolinas and New Brunswick used a whole different system that was based on the original Marconi structure and involved some wave relationships that these later, according to the diagrams, don't use, but something's attempting to be hidden here by somebody. This is the patent of the antenna. Here is the aerial transmission structure. Usually operates at about 100,000 volts. The height is between 300 and 900 feet. And then we have the electrodes that transmit the current in the ground. And what the patent says is this is really a radio antenna, and the electromagnetic waves are coming off of here. But with the overall power flow in this system of inductive exchanges and drive and all that, the energy associated with the electromagnetic field of those virtual conductors is in the less than 10% range. Now this thing was steerable by adjusting the propagation of velocity on this, whether it be slower or faster than light. The velocity was neutralized in the Bolinas-Alexanderson patent, so there was no velocity, in which case it transmitted in all directions. The Navy basically moved in at this point. They're sick of Marconi. He got the boot. Look at his face, huh? Not looking too happy. Yeah, and Navy closed all experimentation. So at any rate, Roosevelt gets the blame, and it was followed through Marconi, Sarnoff, and the experimenters pressured and pressured and pressured. Sarnoff was, writing brutal articles in the Institute of Radio Engineers, and Marconi was agitating by inventing short wave so that all of this would be obsolete, and he could go ha 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 and sail around in his ship and laugh at everybody again. And so it was Herbert Hoover is the one that receives the credit for making radio legal again. So these are what people call Tesla coils. So that's a good view of the extra coil. This is the network that drives it. It's wine bottle, Leyden jars, and zinc-lined saltwater tanks. Very high tech. We have a loading inductance that pulls the inductance up and down on the primary to kind of get it tuned in. We have a switch here because we never want to use solid-state devices in any of these things. It's stupid. So that's why Tesla came up with the high-speed mercury commutator that can operate up to 50 kilocycles a second and have multiple phases, because we just can't be playing with the semiconductor stuff in this neighborhood. Here's the 50 kilovolt adjustable power transformer in the background. It's 50 kilowatts, and it has a 1,000 volt single-phase power line that goes 5 miles back to the generating station, which got burned up from the RF. So now we're going to get a little further into the theories, and I'm going to need my notes for this because there's not a lot of pictures of theory. So all the theories are conflicting. Electron theory, ether theory, electromagnetic theory, all the theories are all basically all patchwork. We really don't quite know what's going on. If I went through here in this matrix of people that I see in front of me, and we asked each and every person what a volt is, there would be an individual answer, and none of them would be right. So now we're going to have to dig our way out of that. So there's only a couple of things we really need. We don't have to get too fancy in this. We don't need to get into all the little details of resistance and conductance and time constants and all that type of stuff. We just want to stick with the basic electricity and not the things that chew and gnaw at it. They get too complicated and they create imbalances that have never been mathematically solved. So the two things that we have in our electrical idea here is magnetism and dielectricity, which really are components of one thing, electrification, as we'll see later. So in order to express these things, It's like what you buy in the store. It might be good to express it in quarts or gallons or some kind of space dimension. So to do this, we have two words. We have one word called inductance, which represents how much magnetism can we hold, and we have another one called capacitance, which is how much dielectricity we can hold. And those two things lay the groundwork for the electrical theory that we're going to develop. So using inductance and capacitance as representations of magnetism and dielectricities, which are divisions of the electrification, these will be the principal elements of electricity, and everything will be defined in those terms. I came up with one of my kind of NFG parables, or a Heaviside story about the theory of electricity. So the theory of electricity came about in some form. Then it was decided that wasn't right, and it was a bunch of bull. So we came up with another theory. So we go by that theory for a while. Well, let's go back to the old one, but a little different, try that one out. Oh, that looks great. Then all of a sudden somebody lands on the deck and they got the big one. Okay, and then all the rest of the theories go in the garbage can. And the big theory is hooted and touted about and all that, but then they found they can't build anything. And it doesn't work. But it's too beautiful, so let's keep it. But now we have to lie, and so we become crazy in our lie. And we make the lie a law, and we have today's electrical theory.